Okay, lesson 8, we're talking about quadratic word problems. So we're going to take all of our quadratic knowledge and put it to work with some word problems. So we're going to be using that zero product rule as we've been working through that, dealing with, okay, we've got our quadratics that are factorable. We have to set them equal to 0 to solve them. Later on next chapter, we're going to learn about solving quadratics using some other methods when quadratics aren't factorable. So it says, consider the rectangle whose area is 45 if we know that the length is 1 less than twice the width. Then we would like to find the dimensions of the rectangle. So if it mentions a geometric shape, I absolutely would draw a rectangle. And then let's label it. So it says the area is 45. So make sure you understand that area means that space inside, and some background knowledge obviously is your area formula for a rectangle is length times width. And it says the length is 1 less than twice the width. So the width we could call it W, and the length is 2W minus 1. I tend to like to label everything on my picture, and chances are I probably just answered A. It says if we represent the width of the rectangle, oh, look at that, using the variable W, then write an expression for the length. We just did that, labeling our picture. So it says set up an equation. Okay, there's a key word, equation. Make sure you got an equal sign in there. That could be used to solve for the width W based on the area. So I've got the formula here that my area equals length times width, and the problem gave us that the area is 45. So A equals my length times my width. I'm going to put the width first just because that's kind of our standard notation. And now what would I do? Okay, so they're asking us just set up the equation, and now part C is going to ask us to solve that equation. So if I take and just rewrite my equation in part C, how would I start to solve that? So hopefully you're looking at that and seeing that W outside the set of parentheses. In your algebra skills, they're saying distribute. So 45 equals 2W squared minus W. So we're in kind of a dilemma here. If we're asked to solve this quadratic equation, what must the equation be set equal to in order to solve it? If you think about it graphically, our solutions are where the graph, or the parabola, crosses the x-axis. So we've got to set it equal to 0. It has to be set equal to 0 in order to factor it. Now we can start the factoring process. I'm going to see if I can shrink this down a little bit. No, clearly I can't. To give me some more space. That's all right. So I'm going to rewrite it. And looking at it, I don't see a GCF, so I've got to start with my sum and product. So I've got to come up with two numbers that are going to multiply to negative 90, but add or sum to a positive 1, and a negative 1, and hopefully you're saying to yourself, negative 10 and positive 9. So when I go ahead and I split the middle there, I end up with 2W squared minus 10W plus 9W minus 45 equals 0. Grouping those two, 2W, and let's put W minus 5 plus 9W minus 5. And now my groups match. Okay, what do they share in common? They share that W minus 5 is one of my factors. And what's left over? 2w plus 9. Keep that set equals to 0, so we factored it, but now let's solve for w. Setting both factors to 0, I end up with w equals a positive 5, and then this other one is going to give me a negative 9/2, okay, or negative 4.5. But think about the context to this problem and what answers make sense. So a width could absolutely be 5, but can a width ever be negative? And hopefully you're saying no, that that's not possible, given that we're talking about a geometric shape. So our width is 5. So I go back up to my picture and just fill in my dimensions. And 2 times 5 minus 1 is 9. Good so far? We do have a live audience. I didn't mean to leave them out. This is Boston again. Sorry, Marine Corps. You guys just didn't make the cut this time. All right, so let's go over to exercise 3. Go ahead, flip the page. Now these 2 questions on this page, dare I say, are kind of boring. At least the one on the front page had a geometric shape to it. This was just kind of some number crunching. So exercise 3 says there are 2 rational numbers that have the following property. So this is where our equation is going to come in. When the product of 7 less than 3 times the number with 1 more than the number is found is equal to 2 less than 10 times the number. I didn't do a very good job of highlighting. That was just kind of like underlining the entire sentence there. Find the 2 rational numbers that fit this description. So we don't know what one of these numbers is, so we're going to say let x equal a number. And we have 2 numbers, so our x is going to be one of them. So now when I take a look at it, and let's kind of pick through this, it says when the product of 7 less than 3 times the number, I have to pause the video because I have to think about this one. Okay, so we went through and we translated that. So we said product means to multiply. 7 less than 3 times the number. That's going to be our 3x minus 7. And then it says with 1 more than the number. So more than is going to be plus 1. And then it says is equal to 2 less than 10 times the number. So 10x minus 2. So now going from there, hopefully you're thinking to yourself, okay, I've got to double distribute. So I end up with 3x squared plus 3x minus 7x minus 7 equals 10x minus 2. Now I could combine like terms and get it set equal to 0 all at once, or kind of take that a step at a time. I'm going to take it a step at a time. So I combine like terms. Now I've got a quadratic here. Anytime you have that quadratic, you've got to set it equal to 0 in order to solve it. So I'm going to subtract 10x and add 2. In other words, I'm moving everything over to one side because it has to be 0 on one side of the equation. 0 equals 3x squared minus 14x minus 5. Okay, go ahead, pause the video and factor that and solve it, and when we come back we'll have that solved. Alright, so hopefully you were able to come up with, whoops, clearly shouldn't use that color, our 2 answers of 5 and negative 1/3. So, but look back into the original question, and it says there are 2 rational numbers okay, that have the following property. Okay? So is 5 a rational number? Okay, yes, it absolutely is. Is negative 1/3 a rational number? Yes, it absolutely is. So those are going to be our two solutions. Always go back, especially in a word problem, solve it, and then go back and make sure that you're answering the question. Let's see. Let's do number 4, and then we'll be done. So we're going back to talking about consecutive integers. It says find all sets. Okay, that's probably going to be a key phrase there. All sets of 2 consecutive integers such that their product is 8 less than 10 times the smaller integer. So let's just do a quick review of what consecutive integers are. Okay, 1, 2, 3, those are consecutive integers. 8 and 9 consecutive integers. Those are one right after the other. We could also say that negative 3 and negative 2 are consecutive integers. So let x equal the first consecutive integer. So then x plus 1 is going to be the second consecutive integer. Now let's write the equation. Such that their product, so we've got to multiply, their product is 8 less than 10 times the smaller integer. 8 less than 10 times the smaller integer. So there's the equation. Now go ahead, start distributing. And again, you've got to set this equal to 0 in order to solve it. So I end up with x squared minus 9x plus 8 equals 0. Factoring sum and product. Negative 8, negative 1. So I end up with x is 8, and I also end up with x is 1. So notice what it said in the beginning, and I underlined it. It says find all sets of 2 consecutive integers. So we came up with 2 answers. So my first integer could be 8, and the second integer could be 8 plus 1, which is 9. So that's a set of answers. But now also think about that, what if x is 1? So x could also be 1, and then 1 plus 1 is 2. So we have 2 sets of answers. Okay, and they kind of tipped us off in the beginning when it said all sets. Probably going to be more than one set. Nice job, guys.